Now I'll be looking at the gate important questions on eigenvalues and eigenvectors. Please look at the previous slides for better understanding. Before that, please like, share and subscribe this particular channel and click on bell icon to get a new notification. Let us start now. Now come to the next question. The question is, eigenvectors correspond to the eigenvalues 1 of a matrix A is. Okay. Now you have to find the eigenvectors for the eigenvalues 1. For this one we know that A minus lambda I of x is equal to 0, right? And the lambda value is given as 1. You have to substitute it and get the x values, right? So just substitute it. We get 1 minus 1 minus 1, 2, 0, 1 minus 1, 0, 1, 2, 1 minus 1, right? Now coming to x values. It's nothing but x, y, and z, okay? Which is equal to nothing but 0, okay? Now substitute these particular values x, y, z and form any equations. Then you get it becomes 0 minus y plus 2z is equal to 0. And all these particular terms are 0 in the second row. So consider third row. So we get that x plus 2y is equal to 0, right? Then we say y is equal to nothing but 2z and x is equal to minus 2y. Let us consider that let z is equal to say alpha. Then we get nothing but y is equal to 2 alpha and x is equal to nothing but minus 2 y is 2 alpha, so it becomes minus 4 alpha. So values of an x, y and z is equal to nothing but alpha times of an minus 4, 2 and 1, right? Alpha can be any value of a real number, so it will be satisfied with the option A. Come to the next question. The question is the product of non-zero eigenvalues of a matrix. The matrix is given, it is an A 5 cross 5 matrix. So we'll be having 5 different eigenvalues. That's not the lambda. Now how to find the eigenvalue is nothing but we have to find the determinant of A minus lambda is equal to 0, right? So just substitute that here. You got a straight line here and a straight line here. So get as 1 minus lambda 0, 0, 0 and this is 1 and this is 0, 0, 0, 1 and this is 1 minus lambda 1, 1 and 0. This is 1, 1 minus lambda 1 and 0 and this is 1, 1, 1 minus lambda and this is 0 and this is 0, 0, 0 and 1 minus lambda. This is a matrix, we got it, right? We have to find the determinant of this one, right? For this one what we do is nothing, we use a general formula minus 1 power I plus j into E of ij, okay, into determinant of a matrix, okay. I and j are nothing but row and columns, so we get this particular terms, okay. Consider the first term 1 minus lambda, so it becomes nothing but minus 1 power, it's an a11, right? First row first column 1 plus 1 into 1 minus lambda, then draw in a straight lines here, here. Do not consider the row and column of this particular a1, okay, first row and first column, so consider only the other terms. So we get as 1 minus lambda 1, 1 and 0. This is 1, 1 and this is 0. The other terms are 1 minus lambda, this is 1 and this is 1, this is 1 minus lambda and this is 0 and this is 0, 0, 1 minus lambda, right? So again consider the other term 1, it is an a1 and it's in a fifth column a5, right? a1 5, so it becomes plus minus 1 power 1 plus 5 into 1 and draw in a straight line here and here. So consider the other terms. Don't consider row and column of this particular first row and fifth column. Consider only the other terms, okay. from here to here. So it 0 0 1 0 0 0 and 1. The next one is 1 minus lambda 1 1 0 1 minus lambda 1 1 0. Another one is 1 this one, right? 1 1 minus lambda 1 and 0. Another one is 1 1 1 1 1 minus lambda and 0, right? Again we got an 4 cross 4 matrix, right? So now 4 cross 4 matrix. Again we have to use the same formula. Okay, so this one becomes nothing but, on substituting this one, it becomes 1 minus lambda into this 1, right? Into 1 into, now here remove the row and column which has an zeros, okay, and we're removing this one and this one, and so only this particular term. So it is A44, right? So minus 1 power 4 plus 4 into 1 minus lambda, and consider the other terms. So draw a straight line here, here. So it becomes 1 minus lambda 1 1 and 1 1 minus lambda 1 and 1 1 1 minus lambda, right? Plus here we'll be considering this particular one. Okay, remove the row and a column. This is an a 1, so it is an a it's an a fourth row and first column, right? 4 1, so it becomes minus 1 power 1 plus 4 into this is 1 into 1, right? So it becomes nothing but 1 into 1. Again draw in a straight line. So it becomes 1 minus lambda 1 1, and this is 1 1 minus lambda and 1, and this is 1 1 1 minus lambda, right? So from here we got that, I'm writing top. So we got 1 minus lambda whole square into this particular matrix. Okay, if you consider this particular matrix, say it is a B matrix, both of them are same, right? Into, I have to find the determinant of an B minus 1 into, you have to find the determinant of an B. So which is equal to nothing but, we can write this one as 1 minus lambda whole square minus 1 into, you have to find the determinant of a matrix B, right? So first we'll find the determinant of this particular matrix. So it becomes 1 minus lambda into 1 minus lambda whole square minus 1, and next term is minus 1, and this is 1 minus lambda minus 1 plus 1 into, it becomes 1 minus 1 plus lambda, right? So these two get cancelled, these two get cancelled, minus 1 get cancelled, becomes 2 lambda, right? So we have to find this particular value now. Now this one is nothing but, it becomes 1 minus lambda into lambda square minus 2 lambda plus 1 minus 1 plus 2 lambda, right? Which is equal to nothing but, we get as this two get cancelled, right? So just multiply these two, it becomes lambda square minus 2 lambda, then it becomes minus lambda cube minus 1 gets cancelled, it becomes plus 2 lambda square, right? 2 lambda square, and it becomes plus 2 lambda, right? So on substituting it, these two get cancelled, right? It becomes nothing but minus of lambda cube plus 3 lambda square, right? So this one we got it B value. So it becomes nothing but, on squaring this particular value, it becomes 1 plus lambda square minus 2 lambda minus 1 into this particular term, it is nothing but lambda cube minus lambda cube plus 3 lambda square, right? So minus plus 8 get cancelled here. So we can write this one as nothing but lambda into lambda minus 2 into lambda square into minus lambda plus 3, right? You have to equate this one to 0, right? You have to get non-zero eigenvalues. You can see that there are 5 eigenvalues, 1, 2, 3, 4 and 5. Non-zero eigenvalues are nothing but this value and this particular. So lambda is equal to nothing but we got as 0, 0, 0, 2, 3. So non-zero values are nothing but 2 and 3. So product of non-zero eigenvalues means lambda is equal to 2 and 3. So product of them is equal to 2 into 3, it is equal to 6, right? So answer is option in the question 6 is the answer. Now coming to next question. The question is number of linear independent eigenvectors. Okay, here the formula is nothing but we know that n minus r, right? So here n is nothing but an order of a matrix. It is given as 2 cross 2 matrix. So order of a matrix is nothing but n is 2 minus rank. You have to find the rank of an a minus lambda, right? So to find the rank of this particular value, first you have to know the lambda value. Here the matrix A is given as 2, 1, 0, 2, right? Now you have to find the value of lambda is how much. You can see that there is nothing but upper triangular matrix, right? Triangular matrix, right? So lambda is nothing but diagonal elements 2, 2. So we have 2 times repeated eigenvalues. So if you consider lambda is equal to 2, okay. Now if you substitute it a minus lambda I, then it becomes 2 minus 2, 1, 0, 2 minus 2, which is equal to 0, 1, 0, 0, right? So it becomes a row matrix 0, 1, 1, right? So the rank of an a minus lambda I is equal to 1. So we got the rank. So it becomes 2 minus 1, which is equal to 1. So number of linear independent eigenvectors is equal to 1. Answer is 1. Next question. The question is number of linear independent eigenvectors of a matrix. And A matrix is given here. Now you have to find the number of linear independent eigenvectors. For that one, you have to first know the eigenvalues, right? Eigenvalues, right? In the case of upper triangular matrix, the eigenvalues are nothing but diagonal elements. Now matrix A is nothing but upper triangular matrix, right? So the eigenvalues are nothing but 2, 2 and 3, right? Now 2 has been repeated twice, right? So in this particular case, number of linear independent eigenvectors, we can find it by n minus rank of an a minus lambda I, right? And 3 is an individual one, so it has an 1 independent eigenvectors plus in the case of 2 repeated things eigenvalues, we have to find the number of linear independent eigenvectors by using this particular formula. So here it becomes another, first find the rank of this particular matrix. So A minus 2i matrix is equal to nothing but it becomes 0, 1, 0, 0, 0, 0, 0, 0, 1, which is equal to nothing but it becomes 1, 0, 0, 1. So rank of this particular matrix, it is 2 cross 2 matrix, right? So rank of an A minus 2i is equal to nothing but 2. We got the value of this one, right? What is n? N is nothing but an order of an A matrix. A is actually 3 cross 3 matrix. So it becomes 3 minus 2, which is equal to 1. So for these two, we got an 1 linear independent eigenvector. And for this one, we got 1. So 1 plus 1 is equal to nothing but 2. So it has an 2 linear independent eigenvectors. Answer is 2. Now based on properties, we will be solving 3 problems. Okay. The first one is eigenvalues of a skew symmetric matrix. We know that it will be 0 or imaginary. So option C, either 0 or purely imaginary. Coming into next question. We have to match the columns 1 and 2 Yes or no? First one, singular matrix. Singular matrix is nothing but they are talking about determinant. Determinant should be 0. So it comes with an option 3. P is nothing but 3. Non-square matrix. If you consider a non-square matrix, it may have 2 rows, right? Like 4, 7. 2 rows and 3 columns. Also, a column is a non-square matrix, right? In this case, determinant cannot be defined. Option 1. So Q is 1. Unreal symmetric matrix. Okay. Uh, Coming to eigenvalues. Okay. Eigenvalues are always real. Option 4. R is 4. Right. Orthogonal matrix. Orthogonal matrix determinant is always 1. Okay. It's option 2. Right. So matching with is option A. Question. The question is eigenvalues and corresponding eigenvectors of 2 cross 2 matrix is given by the eigenvalues lambda 1 and lambda 2 given as 8 and 4, and eigenvectors v1 and v2 given as 1 1 1 minus 1. The matrices, we have to find out which of the matrix would be satisfied with respect to eigenvalues and eigenvectors. For this one, we know the simple one thing, right? Trace of a matrix A is equal to sum of eigenvalues. Yes or no? We know this one, right? So what is the trace of a matrix A? Is nothing but sum of the diagonal elements, right? If you consider matrix A, it is 6 plus 6, which is equal to 12, right? If you consider B, it is 4 plus 4, which is equal to 8. If you consider C, it is 2 plus 2, which is equal to 4. And if you consider this one, it is an 4 plus 4, which is equal to 8. What is sum of the eigenvalues we got at? Is nothing but 8 plus 4. Yes or no? Lambda 1 and lambda 2, which is equal to 2. So which of the options satisfy is nothing but option A. So answer is option A. It's a simple thing, right? If you want to solve it, okay, with this particular matrix, A matrix is given as 6 2 2 6, and the eigenvalues are given as 4 and 8. Yes or no? And we have to find the eigenvectors. Eigenvectors are given as A minus lambda I into x is equal to 0. So just substitute it. We get as 6 minus, consider this one first, 4 term, okay, when lambda is equal to 4, 4 2 2 6 minus 4. So it becomes nothing but 2 2 2 2. Yes or no? And you multiply with an x. So we get as 2 2 2 2 with an x. So if you consider x values as an, consider x value as an x and y, then become x and y is equal to 0. Then we can say 2x plus 2y is equal to 0. Another one is 2x plus 2y is equal to 0. From here we can say that x is equal to nothing but minus 1. Yes or no? So when lambda is equal to 4, then x is equal to minus 5. If x is equal to 1, then y is equal to minus 1. This one got satisfied. Now coming to when lambda is equal to 8, then it becomes this particular matrix would be changing to 6 minus 8 2 2 6 minus 8, right? So which is equal to nothing but it becomes minus 2 2 2 minus 2. Yes or no? Now we have to subtract with an multiply with an x. So it becomes minus 2 2 2 minus 2 with an x and y. Yes or no? So here it becomes nothing but minus 2x plus 2y is equal to 0. Another one is 2x minus 2y is equal to 0. Then we can say x is equal to y. When x is equal to 1, y is equal to 1. So when eigenvalue is 8, so it got satisfied. This is the answer. Okay. The simple way is nothing but just check the trace of an A. Next question. The question is for the matrix 4 2 2 4, the eigenvalue corresponding to eigenvector 101 and 101 is. Okay. Now you have to find the eigenvalue. Okay. where the eigenvector has been given and the A value has been given, right? The general thing that we know is nothing but A minus lambda I into X is equal to 0, right? And we can write this one as A into X is equal to lambda times X, right? So A and X values we know. This is an A matrix, this is an X matrix. So substitute it, we get it as nothing but it is 4, 2, 2, 4. Then X value is given as 101, 101, which is equal to lambda into 101, 101, right? Just multiply these two, we get 4 into 101 plus 2 into 101, and this is also 2 into 101 plus 4 into 101, right? Which is equal to nothing but lambda into 101, 101, right? Now this one matrix becomes nothing but, we can take 101 common, then it becomes 4 plus 2, 6. So we can take 6 common, right? So it becomes nothing but 101, 101 is equal to nothing but lambda times upon 101 and 101, right? So lambda value is nothing but 6. So answer is option C. Now coming to the next question. The question is, all the 4 entries of 2 cross 2 matrix P is equal to P11, P12, P21, P22 are non-zeros. One of the eigenvalue is 0. Which of the following statement is true? We have to find it out in the options which of the following is correct one, right? And they given the P matrix. Now they are saying that one of the eigenvalues 0 means it's nothing but, if you consider lambda 1 and lambda 2, okay, as it is a 2 cross 2 matrix, right? We're having 2 eigenvalues. Then among these two, there be one would be 0 and other would be some lambda value, right? Now one of the value is 0. So we can say that determinant of a matrix P is equal to 0. Yes or no? Find the determinant of this one. Here P matrix is given as nothing but P11, P12, P21 and P22, right? And we have to find the determinant of it. So it is a 2 cross 2 matrix. So determinant of a matrix P is equal to P11 into P22 minus P12 into P21 is equal to nothing but 0. Then only we have one of the eigenvalue 0, right? So option, which of them option satisfied? Option D satisfies, right? Here it is 1, it is a 0. See, check this one also, okay? Now come next question. The question is, the eigenvalue of the following matrix are, you have to find the eigenvalues, right? And they are given the eigenvalues, right? They are given 3 eigenvalues in each of the option. For this particular matrix, we have to find the eigenvalues. If you consider this matrix as an A, okay. Now general thing that we know is nothing but trace of a matrix A is equal to nothing but sum of eigenvalues, right? We know this, right? If we consider trace of a matrix A is nothing but -1, -1 plus 3, right? Should be equal to the sum of the eigenvalues, right? Let the eigenvalues be lambda 1 plus lambda 2 plus lambda 3, right? It is a 3 cross 3 matrix, so it has a 3 eigenvalues. So this one is equal to nothing but 1. So sum of the eigenvalues should be equal to lambda 1 plus lambda 2 plus lambda 3. Eigenvalue should be equal to 1. See the options here. Here 3 plus 3 6 and it becomes -6, right? 3 plus 3 6 and -6. All of these particular things get cancelled and becomes an imaginary number. So this is not an answer. Option D, it's nothing -6, 3 and 3. Now this all the things when you get cancel when you add it, right? And plus j and minus j get cancelled. Again, it's an imaginary number. So option B is wrong one. Come next one. It's nothing but 3, 3 and 5. And plus j minus j get cancelled. And plus j comes into picture. Again, it becomes a complex number. So it is not an answer. Come to next one. It's an 3 minus 1 minus 1. So it is nothing but 1, right? And plus j minus j get cancelled, right? So we are getting 1 in the case of option D. So the eigenvalues are nothing but 3 comma minus 1 plus 3j and minus 1 minus 3j, right? Then when you add it, then we get the value as an 1. So this is an eigenvalues, option D. Now coming to the next question. The question is the three characteristic roots of a following matrix A are. Okay. Now they are asking the eigenvalues. What are the three eigenvalues? You have to find it out. And the matrix are given here. Now if you see this particular matrix, it is nothing but an upper triangular matrix, right? It's an upper triangular matrix. So it will be having the values. Eigenvalues are nothing but the diagonal elements. Are nothing but the eigenvalues of an upper triangular matrix, right? So directly we can say that eigenvalues are nothing but 1, 2 and 2. So it goes with the option B. Next question. The question is the sum of the eigenvalues of a matrix given below is. Okay. The matrix has been given here. We consider this particular matrix as an A. Okay. Now you have to find the sum of the eigenvalues. But we know that sum of the eigenvalues is equal to nothing but trace of a matrix A, right? So trace of A is nothing but summation of a diagonal elements. So which is equal to nothing but 1 plus 5 plus 1, which is equal to 7. So sum of the eigenvalues is option B, 7. Come to the next question. The question is which of the following is an eigenvector of a matrix? And a matrix is given here. For the eigenvalue is 5. They given the eigenvalue is nothing but lambda value is equal to 5. And this is nothing but a matrix A. They are given it. Now you have to find the eigenvector. Which of the following would be matching with it, right? The general thing that we know is nothing but Ax is equal to lambda times of an x, right? So we'll be writing down one by one. Draw a straight line here. Then draw a straight line here. So it becomes 5, 0, 0, 0. And this is 0, 5, 5, 0. This is 0, 0, 2, 1. And this is 0, 0, 3 and 1. Now we'll be writing the x values. Okay. Draw a straight line here. Draw a straight line here. So it becomes x1, x2, x3 and x4, which is equal to nothing but 5 times that of an x, right? So again draw a straight line here. A straight line here. So it becomes x1, x2, x3 and x4. So we can equate these two, right? So we can say that 5 times of an x1 is equal to 5 times of x1, right? So we can say 5 times of an x1 is equal to 5 times of an x1. Again equate these two. Next we're getting 5x2 plus 5x3 is equal to 5x2. And again you're getting 2x3 plus x4 is equal to 5 times of an x3. Another one is nothing but 3 times of an x3 plus x4 is equal to nothing but 5 times of an x4. First we'll be solving this particular two terms, as we have an x3 and x4 common in this particular two equations. So we get x4 minus 3 times of an x3 is equal to 0, right? The first one. And next one is nothing but we get minus 4 x4 and this plus 3x3 is equal to 0. Just add it, right? So it becomes minus 3x4 and these two get cancelled is equal to 0. Then we get x4 is equal to nothing but 0. Okay. Now coming to x3 from this particular equation. Okay, from here we get that as x4 is equal to 0, then we get 0 minus 3x3 is equal to 0. Then x3 is also equal to 0. Again we get x3 is equal to 0. Now coming to x1 and x2. Here we can say that 5x1 is equal to 5x1. So it's nothing but x1 is equal to x1, right? And if you consider this one, here it becomes nothing but x3 is 0. So it becomes 5x2 is equal to nothing but 5x2, right? So x1 we can get any of the real number, right? Now x2 also can be any of the real number, right? So we got x1 and x2 as nothing but belongs to real number, and x3 and x4 are 0. So matching one is nothing but option A. Now coming to next question. The question is eigenvalues of a matrix S are given as 5 and 1, right? What are the eigenvalues of matrix X square? It is asking. The general thing that we know is nothing but if lambda is an eigenvalue of a matrix A, then lambda square are the eigenvalues of an A square, right? Now instead of A they are given as S. So they are given that 1 and 5 are the eigenvalues of an S. Then 1 square comma 5 square and the eigenvalues of an S square. So eigenvalues are nothing but 1 comma 25, right? So answer is option A. Now next question. The question is if a square matrix A is real and symmetric, then the eigenvalues. Okay, they're given that A matrix is nothing but real matrix, right? And they are talking about a symmetric matrix. What is symmetric matrix? Is nothing but when A is equal to A transpose, then it is known as symmetric matrix. Then we know one of the property that eigenvalues of a symmetric matrix will be equal to real numbers. Okay, it can be positive or negative numbers. Okay, if you want you can identify with an I matrix. I is always a symmetric matrix like 1 0 0 0 1 0 0 0 1. Okay, then we get an eigenvalues lambda is equal to 1 comma 1 comma 1. If you consider minus I, okay, then we get minus 1 0 0 0 minus 1 0 0 0 minus 1, right? Then we get an eigenvalues as nothing but minus 1 minus 1 and minus 1, right? So always remember that for symmetric matrix, okay, we have an eigenvalues always real, positive or negative. So answer the option A. Our next question. The question is number of linear independent eigenvectors of a matrix. Okay, they given a matrix. Now you find the number of linear independent eigenvectors. If you consider this matrix as an A matrix, okay, so they given the A matrix is equal to nothing but given us 2 1 0 2. Now we have to find number of linear independent eigenvectors. For this one you have to know the eigenvalues, right? Now if you see this one, this is nothing but an upper triangle matrix, so it has an nothing but eigenvalues are nothing but 2 comma 2, right? Now if you consider the number of linear independent eigenvectors in the case of repeated eigenvalues is given as n minus rank of an A minus lambda I, right? So where n is nothing but order of matrix A, it is 2 cross 2 matrix, so n is nothing but 2 minus rank of A minus lambda I. Lambda is given as 2, so we have to find the rank of an A minus 2I. So substitute it, we get the A matrix A minus 2I is equal to nothing but it becomes 2 minus 2 1 0 2 minus 2, which is equal to nothing but it becomes nothing but 0 0 1 0. So which is equal to nothing but it becomes a column matrix, right? So rank of a column matrix A minus 2I is equal to 1. So it is nothing but 1. So 2 minus 1 is nothing but 1. So we have only one linear independent eigenvector. So answer the option B. Now coming to the next question. The question is, the matrix has one eigenvalue equal to 3. The sum of the other two eigenvalues is, and they are given the 3 cross 3 matrix. Right? In 3 cross 3 matrix, we know that the eigenvalues are nothing but lambda 1, lambda 2, and lambda 3. Right? And they are given the one of the eigenvalue as an a 3. Let us consider lambda 1 is equal to 3. Now we have to find the value of lambda 2 plus lambda 3 is equal to how much? Right? And the question. Now the general thing that we know is nothing but trace of a matrix E is equal to nothing but sum of the eigenvalues, which is equal to nothing but lambda 1 plus lambda 2 plus lambda 3. So trace of A is nothing but sum of the diagonal elements. So it becomes 1 plus 0 plus P, which is equal to nothing but lambda 1 we consider as 3 plus lambda 2 plus lambda 3. Now you have to find the value of lambda 2 plus lambda 3 is equal to nothing but it becomes P plus 1 minus 3, which is equal to P minus 2. Right? So which is nothing but sum of the two eigenvalues. So answer is option C. Now next question. The question is, the eigenvectors of a matrix 1, 2, 0, 2 are written in the form of 1A and 1B. What is any A plus B? Now they are given a matrix, right? So A matrix is given as nothing but 1, 2, 0, 2, right? Again they are given the eigenvectors. So consider two eigenvectors. So x1 is equal to given as 1A and x2 eigenvector is given as 1B, right? Now we have to find the value of A plus B. For this one, first you have to know the eigenvalues, lambda 1 and lambda 2, right? Now if you see this particular matrix, this is an upper triangular matrix. So eigenvalues are nothing but diagonal elements 1 and 2. So it is 1 and 2. Now consider the lambda 1, which is equal to nothing but 1. The general formula that we know is nothing but A x is equal to lambda times upon x, right? Now consider first case, lambda 1. Then it becomes x1, lambda 1, x1, right? So just substitute it becomes 1, 2, 0, 2. And x1 is given as 1 and A is given as 1A is equal to nothing but 1 into 1A, right? So just substitute it becomes 1 plus 2A is equal to 1. And this one is nothing but it becomes 2A is equal to A. Now in this particular case, you can see that 1 can be equal to 1 when A is equal to nothing but 0. Right? 2A is equal to A when A is equal to 0. So we got the value of an A. Now consider lambda 2 is equal to nothing but 2. Just substitute it. A into x2 is equal to lambda 2 times x2. Then we get 1, 2, 0, 2. Right? x2 is given as 1 and b is equal to 2 into 1b. Right? Then we get 1 plus 2b is equal to nothing but 2. And 2b is equal to nothing but 2b only. Right? So b is equal to b, we got it here. Now here we get nothing but b is equal to nothing but 1 by 2. Right? So a and b value we got it. So we have to find the value of a plus b, which is equal to 0 plus 1 by 2, which is equal to nothing but 1 by 2 only. So answer is option B. Now come to the next question. The question is, the minimum maximum eigenvalues of a matrix are minus 2 and 6 respectively. What is the other eigenvalue? Okay. Now it is given as 3 cross 3 matrix. Right. So it has an 3 eigenvalues. So consider that it is an lambda 1, lambda 2 and lambda 3. Right. So they are given the 2 eigenvalues, given as minus 2 and 6. Now we have to find the value of lambda 3. The basic thing that we know is nothing but trace of a matrix A is equal to nothing but sum of eigenvalues, right? The basic thing that we no 8. Right? Now if you consider this matrix as an A matrix, then trace of a matrix is nothing but sum of the diagonal elements. So it becomes 1 plus 5 plus 1, which is equal to nothing but sum of the eigenvalues, which is equal to nothing but lambda 1 plus lambda 2 plus lambda 3. Right? So this one becomes nothing but 7 is equal to lambda 1 plus lambda 2 is nothing but minus 2 plus 6 plus lambda 3. So lambda 3 is equal to nothing but it becomes 7 minus 4, which is equal to 3. So other eigenvalue is nothing but option B, 3. Now come to the next question. The question is, for matrix B, one of the eigenvalue is minus 2. Right? Then which of the following is an eigenvector? Now you have to find for eigenvalue minus 2, which of the following would be an eigenvector, right? So they give the eigenvalue as an minus 2, right? Now the general thing that we know is nothing but A into X is equal to lambda times of an X. A value is nothing but P value. So just substitute it. We get nothing but 3 minus 2, 2, 0, minus 2, 1, 0, 0, and this is 1. Right? Now coming to X values. If you consider this but X values as X, Y, and Z. Okay, and which is equal to nothing but lambda is given as minus 2 into X, Y, and Z. Just substitute it and get the equations. Then we get 3x minus 2y plus 2z is equal to minus 2x. The other one is minus 2y plus z is equal to minus 2y. The other one is nothing but z is equal to minus 2z. Right? Now coming from the bottom, z cannot be minus 2z. Yes or no? It can be happen when z is equal to nothing but 0. So we got the z value is equal to 0. And z is equal to 0. Substitute in this particular equation. Then we get minus 2y is equal to minus 2y. It's nothing but y is equal to y. Then y is nothing but a real number. Okay. Now substitute in this particular equation. Then we get 3x minus 2y plus z is 0. 0 is equal to minus 2x. Right. Then we get 5x minus 2y is equal to 0. Then here on substituting we get x is equal to nothing but 2y by 5. Right? Now see the options. We got a z is equal to 0 in the D option only. Okay. When y is equal to 5, then we get x is equal to nothing but 2. Right? So it is got satisfied with the option D. Come to the questions. The question is, Cayley-Hamilton theorem states that square matrix satisfies its own characteristic equation. Consider matrix A. They are given as 2 cross 2 matrix. Right? Now they are saying A can be satisfied the relation in terms of a polynomial. They are given it, right? Then A power 9 is how much? We have to find it out. First, what are you going with this particular question? First one. Now the general characteristic equation is known as A minus lambda I is equal to 0, right? We know that A is a matrix given here. I is an identity matrix. So just substitute it. We get minus 3 minus lambda 2 minus 1 minus lambda. Find the determinant of this one. So it becomes minus 3 minus lambda into minus lambda plus 2, which is equal to nothing but becomes lambda square plus 3 lambda plus 2, which is equal to 0, right? This characteristic is 0. So we can write this one as lambda plus 1 and lambda plus 2 is equal to 0. Now what you do is nothing but replace lambda with an A. Then we get A plus 1. Means we consider this one as identity matrix. Okay. Then A plus 2. is equal to 0. So it comes with the option C. Now when we're doing with an a power 9, you have to find the value of a power 9 is equal to how much? We can write this one as nothing but a power 4 whole square into a, right? The general thing that we know is nothing but this particular equation, right? So we can write this particular equation as a square plus 3a plus 2i, right? So we got this particular equation, right? So we can write a square is equal to nothing but minus of 3a plus 2i, right? Now we have to find the value of a power 4. Then it becomes minus 3a plus 2i whole square of it, right? So it becomes nothing but 9a square plus 12a plus 4i, right? But we know that a square is equal to minus of 3a plus 2i. So just substitute it. We get this one as 9 into minus of 3a plus 2i plus 12a plus 4i, right? So it becomes nothing but minus of 27e minus of 89 plus 12a plus 4i, right? Which is equal to nothing but just subtract these two. Get us minus 15a minus 14i, which is equal to a power 4. Now define the value of a power 8. We just squaring of this particular value. We get this minus 15a minus 14i whole square, which is equal to nothing but 15 square becomes 225a square plus 15 to 14 into 2, it becomes 420a plus 196i. But we know the a square value minus of 3a plus 2i, right? So just substitute the values here. We get 225 into minus 3a minus 2i plus 420a plus 196i, right? So again, if you substitute it, you get the values as 225 into 3. It becomes minus 675a minus 2 into 225. It becomes 450i plus 420a plus 196i. So just subtract it, we get as a power 8 is equal to 255 minus a and minus 254i. Now we define the value of a power 9, which is equal to nothing. Just multiply this one with an a. So it becomes minus 255 a square minus 254 a, right? This one a power 8 is multiplied with an a. We know the a square value, so it becomes minus 255 into minus of 3a minus 2y minus 254a, right? So just multiply again. 255 into 3, it becomes 765a plus this one, it becomes 510i minus 254a, which is equal to a power 9, right? So subtract these two, we get as nothing but 511a plus 510i is equal to a power 9. So it goes in option A. Next question. The question is, we're defining the eigenvalues by using a shortcut method. Okay. Now in this particular question, they are asking to find the eigenvalues, right? Now we'll be using this particular formula to find the eigenvalues, right? So it is given as lambda cube. So it is in a lambda cube minus lambda square trace of an A. What is in trace of an A? E. It is equal to nothing but sum of the principal diagonal elements. So it becomes 8 plus 7 plus 3, which is equal to nothing but 18, right? So it is 18 plus lambda times of an A, sum of the minus of an A, A11, A22 and A33 is nothing but defining one by one. What is A11? It is 8, right? So minor of it, we're defining it out. A11, we got the value as nothing but we have determinant of, if you remove the A11, the row and the column will be removing it, then we get in a 2 cross 2 matrix. It is given as 7 minus 4 minus 4 3, right? Now coming to A22, it is an A22, right? Now we'll be removing the row and the column, so the remaining elements are 8 2 2 3, right? Again coming to A33, A33 is nothing but 3, right? So we'll be removing the row and the column. The other elements are nothing but 8 minus 6 minus 6 7, right? Now defining the determinant of each one of it, so it becomes 7 into 3 minus minus of minus, it becomes 4 into 4, right? 7 into 3 21 minus 16, right? It becomes 5. Again find the respective value. It comes 8 3 is 24 minus 2 to the 4, which is equal to 20. Again here it becomes 8 7 is 56 minus 36, which is equal to 20. So it will be adding all of them. It becomes 5 plus 20 plus 20, right? And minus determinant of an A, we have to find it out. Find the determinant of this particular matrix. Determinant of an A is equal to, the first term is 8. 8 into 7 3 is 21 minus 4 4 is 16. Minus minus get cancelled and becomes plus. 6 into 6 3 is 18, becomes minus 18. And here it becomes plus 8 plus 2 times of an A. Here 6 4 is 24 minus 7 2 is 14, right? So it becomes 8 into 5 plus 6 into minus 10 plus 2 into 10, right? So 8 5 is 40 minus 16 plus 20, which is equal to 0. So we got the value as an 0 is equal to 0, right? So we get lambda cube minus 18 lambda square plus the sum of this one is nothing but 45. 45 lambda is equal to 0. If you consider lambda common term, then it becomes lambda square minus 18 lambda plus 45 is equal to 0. This term we can write in the form of lambda into lambda minus 15 and lambda minus 3 is equal to 0. So lambda is equal to nothing but as 0, 15 and 3. These are the eigenvalues by using an alternative method or shortcut method to find the eigenvalues. Okay. Next question. The question is, how many of the following matrices have any eigenvalues 1? Okay. And they are given the 4 matrix A, B, and C and D. Right. So consider this particular 4 matrix as A, B, C, D. Now you have to find the eigenvalues for it. So if you consider matrix A, it is given as nothing but 1 0 0 0. Right. So it is nothing but a diagonal matrix. So eigenvalues of a diagonal matrix is nothing but diagonal elements. So it becomes 1, 0. Now coming to P, which is equal to nothing but 0, 1, 0, 0, right? It's an upper triangular matrix. So eigenvalues are nothing but diagonal elements. So eigenvalues are 0, 0. Now coming to C, which is equal to nothing but given as 1, minus 1, 1 and 1, right? Now we define the eigenvalues. Now the general formula we use to find the eigenvalues is nothing but determinant of A minus lambda I, right? Now here A is nothing but C. So we get nothing but substitute. We get 1 minus lambda minus 1, 1, 1 minus lambda. Find the determinant. So we get as 1 minus lambda whole square plus 1, which is equal to lambda square minus 2 lambda plus 1 plus 1, which is equal to lambda square minus 2 lambda plus 2. Now we'll be using a formula to find the roots of it. The general formula that we know is nothing but minus b plus or minus root of b square minus 4ac by 2a. Right, then we get nothing but 2 plus or minus root of 2 to the 4, and it is nothing but minus of and minus 4 to the 8 by 2a, right? So which is equal to nothing but 2 plus or minus, and it is a 2j by 2, which is equal to we get as 1 plus or minus j, right? So eigenvalues for C is nothing but lambda is equal to 1 plus or minus j. We have two eigenvalues. Now coming to D matrix, which is equal to nothing but given as minus 1, 0, 1 and minus 1, right? So eigenvalues for it. It's a lower triangular matrix. So eigenvalues are nothing but diagonal elements, minus 1 and minus 1. Now they are asking how many of the following matrices have an eigenvalue 1. Only A matrix have an 1, right? So answer is option A. Now coming to the next question. The question is eigenvalues of 3 cross 3 matrix P are 2 to minus 1. P inverses. Now the P matrix is not given. Only the eigenvalues are given, right? So what we do in this particular case is nothing but keep the eigenvalues in a diagonal matrix. Okay, it's nothing but P matrix is equal to nothing but it becomes 2, 0, 0, 0, 2, 0, 0, 0, minus 1. What you have done is nothing but eigenvalues are kept in a diagonal. So in a diagonal matrix, eigenvalues are nothing but in a diagonal matrix. So we form a matrix. Now we have to find the value of P inverse, right? For this one, what we do is nothing but the general thing that we know formula is nothing but determinant of an A minus lambda I is equal to 0. We know this one, right? Now instead of A, it is a P. Okay, it is a P. Now we'll be finding this particular determinant. So it becomes determinant of 2 minus lambda 0, 0, then 0, 2 minus lambda 0, 0, 0, minus 1 minus lambda, right? Now in this particular case, right, we have only diagonal elements. So determinant is equal to nothing but 2 minus lambda into 2 minus lambda into minus 1 minus lambda, which is equal to nothing but it becomes lambda square minus 4 lambda plus 4 into minus 1 minus lambda, right? So which is equal to nothing, it becomes minus lambda square plus 4 lambda minus 4 minus lambda cube, then minus minus plus 4 lambda square minus 4 lambda, right? So here 4 lambda get cancelled, so which is equal to nothing but minus lambda cube, and this one and this one it becomes plus 3 lambda square minus 4 is equal to 0. Now we got this particular equation, right? Now if you remove the minus and keep a minus across an 3, then it comes lambda cube minus 3 lambda square plus 4 is equal to 0. But we have to find the value of P inverse. As we know that when you replace lambda with an a P, right, it forms an a matrix, right? Now we'd be replacing lambda with a P and constant with an a I values, okay? Then becomes P cube minus 3 P square plus 4 I is equal to 0. Then we can write this one as nothing but P cube minus 3P square is equal to minus 4I. Now we'll be multiplying both the sides with an a P inverse, okay? We'll be multiplying it. Then we get P cube minus 3P square whole with an a P inverse is equal to minus 4I into P inverse, right? So it becomes P square minus 3P is equal to nothing but minus 4P inverse. You have to get the value of P inverse, and P inverse is equal to nothing but it becomes 1 by 4 into, as minus is there, so it becomes 3P minus P square, right? So we got a P inverse. So in the options, the correct one is nothing but option A. Now coming to the question. The question is, if I given 2 across to matrix A, it is observed that A into column matrix is equal to minus of some column matrix, and A into some column matrix is equal to minus 2 times of a column matrix. The value of A is, okay. Now if you see this one, it is in the form of A into X is equal to lambda times of an X. Yes or no? So we can see that lambda value is equal to nothing but minus 1 comma minus 2, and x1 value is equal to nothing but 1 minus 1, and x2 value is equal to nothing but 1 minus 2. These are my eigenvectors. These are my eigenvalues. Now you have to find the value of an A. The basic thing that we know is nothing but A is equal to nothing but P into D into P inverse, right? What is a P? It's a combination of vectors, right? So eigenvectors. So it becomes P is equal to nothing but 1 minus 1, 1 minus 2. What is D? Is nothing but diagonal elements are nothing but eigenvalues. So it becomes minus 1, 0, 0, minus 2, right? So we have to find the value of P inverse, which is nothing but it is 2 cross 2 matrix. So it becomes 1 by minus 2 plus 1 into minus 2, 1, minus 1, 1. Right, just multiply it. We get this one as it becomes minus 1. So it becomes 2, 1, minus 1, minus 1. So A value is equal to nothing but P. P is nothing but 1, 1, minus 1, minus 2. D is nothing but minus 1, 0, 0, minus 2. And P inverse is equal to nothing but 2, 1, minus 1, minus 1. Is an A value. So we can see that in the option, it got satisfied in the option C. So answer is C. Now coming to next question. Question is, consider a system of equation A and X is equal to lambda into X, where lambda is a scalar. Let lambda and X be an eigenpair of eigenvalues and its corresponding eigenvectors for real matrix A. Let I be enclosed an unit matrix. Which of the following statement is not correct? They ask, right? First, we'll be saying that A value. For a homogeneous enclosed system of linear equation, A minus lambda I X is equal to 0, having non-trivial solution, then rank of A minus lambda I is less than n. What they are saying is nothing but rank of an A minus lambda I. If it is less than n, then we have non-trivial solution. As no, it's a true value. So option is correct. Now going to option B. Now they are saying for matrix A per m, m being a positive integer, lambda per m x by m will be eigenpair for I. What they are saying nothing but if A is a matrix, okay, then lambda is an eigenvalue and x is an eigenvector. And if you consider A power m, then lambda power m is nothing but eigenvalue. Now coming to x power m, eigenvector. When A power m we have, then we have x power m eigenvector? No, right? It is a wrong one. So option B is wrong. Going to option C. A transpose is equal to A inverse. It's nothing but A into A transpose is equal to I. Or A transpose is equal to A inverse. It's nothing but orthogonal matrix. Then eigenvalues will be plus or minus 1. So option C is correct one. A transpose is equal to A is nothing but symmetric matrix. Yes or no? When it is symmetric matrix, A transpose is equal to A. Then lambda is a real value. Eigenvalue is a real value. So option D is also correct. So they are asking which of the following statement is not correct. So we can see that B option is not correct. So answer option B. Now come to the next question. The question is for matrix A satisfy the equation given below. The eigenvalues are. So they are given the A matrix, and if you consider this as a B matrix, and this is nothing but a C matrix. Okay. Now the general thing that we know in the case of an eigenvalues is nothing but A into X is equal to lambda times of an X, right? Where X is nothing but an eigenvectors, right? Lambda is an eigenvalue and A is a matrix, right? Now what we do is nothing but if you see here, B and C are different and lambda value has not been given, right? When you compare this one with this particular matrix, so what they are given is nothing but A into B is equal to C, right? Now what we do in this particular case is nothing but find determinant. If you find the determinant of an A, this particular equation, determinant of an A into determinant of X is equal to lambda is a scalar value, lambda into determinant of an X, right? So these two values get cancelled. So we can say that determinant of a matrix A is equal to nothing but lambda. Yes or no? We know that determinant of matrix A is nothing but product of eigenvalues, right? Eigenvalues, right? Now it is given as 3 cross 3 matrix. So we'd be having 3 eigenvalues. Say it is in lambda 1, lambda 2 and lambda 3. And its product of this one is given as nothing but a lambda. Now what we do in this particular also is nothing but find a determinant of A, B, C. So determinant of an A into determinant of an B is equal to determinant of an C. But if you see the matrix properly, A, B, here the row 2 of an A, B matrix is equal to row 3 of an C matrix, and row 3 of an B matrix is same as a row 2 of an C matrix, right? So there's just a row change. So we know the general formula that when the determinant, finding the determinant, if the row changes, then the sign would be changing. So we can say that determinant of B matrix is equal to minus of an determinant of a C matrix, right? So substitute here, get as A into B. B is nothing but a minus of determinant of a C. So it is minus 1 into determinant of a C is equal to determinant of a C. Now this particular determinants are the scalar values got cancelled. So we can say that determinant of a matrix A is equal to nothing, which is equal to nothing but minus 1, right? So we can say that the product of an eigenvalues lambda 1, lambda 2 and lambda 3 is nothing but minus 1. So we'll be checking the options. It is given as 1 into minus j into j, right? J into j minus 1, minus 1 into minus plus into 1. So it is equal to 1. So looking at the option B, 1 into minus 1, right? So which is equal to minus 1. Again we're looking at this particular thing. 1 into 1 into 0, which is equal to 0. And here 1 into 0 into 0, which is equal to 0. But we have to get the minus 1 when you multiply the eigenvalues. So it is going with option B. Now coming to the eigenvectors of a matrix. Okay. Now for this particular matrix, we have to find the eigenvectors. If you consider this particular matrix as an A. Okay. Now general formula that we know is nothing but Ax is equal to lambda x. Where x is nothing but eigenvector, lambda is nothing but eigenvalues, right? Now if you consider x as in a column matrix containing 3 elements, that is a 3 cross 3 matrix, right? A is a 3 cross 3 matrix. So x would be having 3 rows. So it becomes x, y, and z, right? Just multiply it, a with an x. So we get as nothing but an 1 1 0 0 2 2 0 0 3, right? And it has been multiplied with an x, which is nothing but x, y, and z, and which should be equal to lambda is a scalar value into x, y, and z, right? So just multiply it, then we get x plus y should be equal to lambda x, and 2y plus 2z should be equal to lambda y, and 3z should be equal to lambda z, right? So from the last equation, okay, you can see that lambda is equal to nothing but 3. Now if lambda is equal to 3, then z is equal to z. If you consider z is equal to 1, then substitute in this particular equation, then we get 2y plus 2 is equal to nothing but 3y. Then we get y is equal to nothing but 2. Now we got in a y value, right? Now coming to here x plus 2 is equal to 3x, which implies we get 2x is equal to 2, which implies x is equal to nothing but 1, right? So we got a matrix which is equal to nothing but 1, y is 2, and z is 1, right? And when you do the transpose of this, it becomes nothing but 1 to 1. Transpose is nothing but this particular values. So it goes with option B. Next question. The question is, consider 3 cross 3 symmetric matrix S such that two of the eigenvalues are A not equal to 0, B not equal to 0, and expect two eigenvectors x1, x2, x3, y1, y2, y3. If A is not equal to B, okay, then x1, y1 plus x2, y2 plus x3, y3 is equal to how much? We have to find it out. Now we'll understand the question properly. It is given that S is a symmetric matrix. So we can consider that S is a symmetric matrix, right? So we can say that S is equal to S transpose, right? Again, they are given the eigen values A and B. So they are given the eigen values as A not equal to 0, B not equal to 0, right? And their respective eigenvectors are given, right? If you consider this as an P matrix and this one as an Q matrix, okay, then they are given the eigenvectors as P and Q, right? Again, they are saying if A is not equal to B. So in eigenvalues, they are given A is not equal to B. Then they are given the equation. It is equal to how much we have to find it out, right? Now, how to get this particular equation? First, you have to think about it. If you do Q transpose into P, it becomes nothing but y1, y2, y3. You are multiplying with a P matrix, x1, x2, and x3, right? So it becomes nothing but x1, y1 plus x2, y2 plus x3, y3, right? So we form an equation by multiplying x transpose into P. Now, general thing that we know is nothing but A into x is equal to nothing but lambda times of an x, right? where A is a matrix and X is an eigen vector, lambda is an eigen value. Now, by knowing this one, we are substituting all these particular equations. Okay, we know that S into, if you consider A, then its eigenvector is nothing but P is equal to A into P, right? The other one is nothing but S into Q is equal to B into, is nothing but Q, right? If you consider this one as an nothing but equation 1 and this one as an equation 2. Now in the equation 1, we'll be multiplying, okay? Multiplying with an Q transpose. It is Q transpose into S into P is equal to A into Q transpose into P. As we know, E is a scalar value, right? Now S is given, but S is called nothing but X transpose. We know that. So substitute it, we get Q transpose into S transpose into P is equal to nothing but A into Q transpose into P, right? Now in a symmetric matrix, we know one more thing, that A into B whole transpose is equal to B transpose into A transpose, right? So we can keep this one in a form of a brackets. So we get us nothing but S into Q whole transpose into P is equal to A into Q transpose into P. But we know that S into Q is equal to B into Q. So it becomes nothing but B into Q transpose P is equal to A into Q transpose into P. So we get as B minus E into Q transpose P is equal to 0. Here they given that A is not equal to B, right? Then we can say that the spectral term is 0. So Q transpose into P is equal to 0. What is the Q transpose into P? Is nothing but this particular equation, right? This equation is nothing but Q transpose into P. So its value is nothing but 0. So answer option D. Now coming to the next question. The question is minimum eigenvalue of a matrix. The matrix is given if you consider this as an A matrix. Okay. Now the A matrix is given as nothing but 3, 5, 2, 5, 12, 7, and 2, 7, and 5. This is a matrix given, and we have to find a minimum eigen value, right? If you see properly, this is a row 1, this is a row 2, and this is nothing but a row 3, right? Now we can see that row 2 is equal to nothing but row 1 plus row 3. Then we can see that determinant of a matrix A is equal to nothing but 0, right? So when the determinant of a matrix is 0, then the one of the eigenvalue would be nothing but lambda would be equal to 0. So they are asking for the minimum eigenvalue. So in the option, only A would be the answer. Now coming to the next question. The question is, if the matrix 1, 2, 3 is an eigenvector of a matrix, is given as 4, 1, 2 of P 2, 1, 14 minus 4, 10. Then the value of P is. You have to find the value of P in this particular matrix, right? If you consider this matrix as an A, okay, and this particular matrix is an X, which is nothing but eigenvectors. The general thing that we know is nothing but A into X is equal to lambda into X, right? Where X is nothing but an eigenvector, lambda is an eigenvalues, right? So we'll be substituting each one. A matrix is given as nothing but 4, 1, 2, P, 2, 1, 14 minus 4 and 10, right? And coming to X matrix. X matrix is given as 1, 2, and 3, right? It is equal to nothing but lambda into, it is given as 1, 2, and 3. Now we are multiplying these two matrices and equating into the other matrix. So it becomes nothing but 4 plus 2 plus 6 is equal to lambda. The other one is P plus 4 plus 3 is equal to 2 lambda. The other one is 4 minus 8 plus 30 is equal to 3 lambda. Okay, first what you know in the lambda value, from that one you know in the p value. If we substitute here, then we get lambda is equal to nothing but 6, 10, 12. It becomes 12, right? So here substitute it, then we get p plus 7 is equal, which is equal to 2 into 12. So we get p is equal to 24 minus 7, which is equal to 17, right? So p value is nothing but 17. Answer is 17. Next question. The question is the value of an x for which the matrix A has an 0 as an eigenvalue. Okay. Now they are saying that eigenvalue lambda is equal to 0. Then we can say that determinant of a matrix A should be equal to 0. So we have to find the determinant of this particular matrix and find the value of an x. So which is equal to nothing but find the determinant of 3, 2, 4, 9, 7, 13, minus 6, minus 4, minus 9 plus x, right? So it becomes nothing but 3 into, this is 7 into minus 9 plus x, minus minus got and becomes plus 4 into 13 minus 2 into, it becomes 9 into minus 9 plus x, right? And this is 9 minus minus goes and it becomes plus 6 into 13, right? And it becomes plus, it is 4 into, it becomes minus 4 into 9, minus minus goes, it becomes plus 6 into 7, right? Now if you substitute this one, 4 into 9 minus 36 plus 42, and on subtracting these two we get as nothing but a 6. So here it is 4 into 6, so the whole thing is nothing but 4 into 6, which is equal to 24. Now coming to this one, if you substitute this particular values, okay, it is minus 9 into 7 is 63 plus 7x plus, and 4 into 13 52, right? Minus 63 plus 52, it becomes minus 11 plus 7x, right? And we are multiplying with a 3, so this one becomes nothing but, it becomes minus 33 plus 21x, right? Then come to here, these terms, right? Minus 9 into 9, right? It becomes minus 81 plus 9x plus, this is 6 into 13 is nothing but 78, right? Again minus 18 and 17 8, it becomes minus 3 plus 9x, and we are multiplying with a minus 2, so it becomes nothing but plus 6, and this is minus 18x, and this is plus 24, right? 6 plus 24 30, minus 33, it becomes minus 3 plus, this is 21x with an 18x, right? So which is equal to nothing, it becomes 3x, which implies x is equal to nothing but 1. So answer is 1. Next question. The question is, consider 2 cross 2 square matrix where A is equal to row x, w, and row, where x is unknown. Okay, if the eigenvalues of a matrix A are rho plus j omega and rho minus j omega, then x is equal to, they are asking, right? For this one, we know one thing, that determinant of a matrix A is equal to nothing but product of an eigenvalues, right? So in this particular case, they given a 2 cross 2 matrix, right? So we have a 2 eigenvalues, say lambda 1 and lambda 2. They given the values of it, right? 2 eigenvalues. This is lambda 1 and this is a lambda 2, right? Is equal to nothing but a determinant of a matrix. So find the determinant of this particular matrix. It becomes nothing but determinant of a row x, w, and row is equal to nothing but rho minus j omega into rho plus j omega. So it becomes rho square minus wx is equal to rho square plus w square, right? Rho square get cancelled, right? Here one of the w get cancelled here, so x is equal to nothing but minus w. So answer is option D.